Was there anybody who was gone yesterday? Okay, so I did not record the lesson yesterday. Actually, I did record it, but I forgot to press stop, so it ended up being a 6-hour-long video. And I didn't want to try to save that to my computer, so I just deleted it, okay? So thank you for the laughter. All right, so we pick up with letter F. Yesterday you learned two important pieces. Number one, the antiderivative of e to the x is e to the x. And the antiderivative of natural log of x is, the antiderivative of 1 over x is, right. So the question here is this of the form integral of e to the u, or is it integral of 1 over u? Talk to your friend, and try to decide. Go, talk. Which one is it, why?
Probably is both. Oh my God. Holy moly.
Five, 4, 3, 2, 1. Miss Marissa, what is it?
1 over u.
It is 1 over u. If you notice, if you chose u to be e to the x minus 1, then du is, what is the derivative of e to the x minus 1? It is e to the x, dx. So therefore you can see that your substitution is complete. So I have the integral of, all I do is I place du there, and I get to cross off e to the x and dx. What remains? 1 over u. And the antiderivative of 1 over u is the natural log of the absolute value of u, which is e to the x minus 1, right? And so we are going to evaluate that at 4 and at 2. So I have the natural log of what? Yep. E to the 4th minus 1. Okay. That's going to be positive, so I don't need to use the absolute value sign anymore. Minus the natural log of e to the 2nd minus 1. And that will not be listed as the answer on the AP exam. In fact, this is directly from an AP problem. You divide. Natural log of e to the 4th minus 1 over e to the 2nd minus 1. And that will not be the answer. You factor it out because you have the difference of 2 squares on top, don't you? You also have the difference of 2 squares on bottom, but that's not going to help us. It's the natural log of e squared minus 1 times e squared plus 1 over e squared minus 1. Notice how those cancel. You get the natural log of the quantity e squared plus 1. That is your answer. We're good? Yes.
So where did
the absolute value, because this is going to be positive, e to the 4th minus 1 is a positive value. We don't need to include the absolute value anymore.
But there's minus 1. How's that possible?
Try to take e to the 4th. It's around like 60. So you'd have 60 minus 1 is 59. Okay. All right, flip it over. Yesterday were the basics. This is not the basics, and this is, if you get problems wrong on this test, here's where it starts to happen. It is very important that you understand the difference in the types of problems, and you're going to see some new ones now. The problem that you see here, I'm going to write this slightly differently. I'm going to write it as the integral of 3e. Instead of writing 1 over x to the 4th, I'm going to write it as x to the negative 4th power. And instead of a 1 over x to the 5th, I'm going to write it as times x to the negative 5th power. Now, you don't have to do that, but I'm trying to do that, see if that helps people in their understanding. Okay. What do you think? Yes, this is a e to the u problem. What is u in this situation? X to the negative 4th. What is du? Negative 5, we subtract 1 on the derivative. See why I rewrote it for you so you could see it in that format? So I have a dx attached to that. I don't want the negative 4, I want the 3, so I will. Negative 3/4, very good. Du is equal to 3x to the negative 5 dx. Notice how you have a 3x to the negative 5 right there. So my substitution is negative 3 over 4 integral what? E to the u. And the antiderivative of e to the u is? E to the u. So I get negative 3 over 4 e to the, and this is x to the negative 4, or 1 over x to the 4th, plus a constant. So I've learned a lot about you guys. Number one is that I will miss you next year as you graduate. You're a fun class. I've also learned that sometimes you struggle with this whole exponent thing, top, bottom, negative, positive, stuff like that. So mind your P's and Q's and stuff as you're going through that. Okay. All right. Letter H. Can you identify? Is this going to be an e to the u or a 1 over u? It is going to be a 1 over u, and it's kind of hard to see why. But if you think about this, just try a substitution. What is u in this problem, do you think? It's the natural log of x because it's that thing being squared. Watch what happens. If we say u is the natural log of x, then what is du? 1 over x dx. And you have an x in the denominator, don't you? Multiplied by 1/4. So 1/4 du is equal to 1 over 4x dx. Looks like I have my substitution. 1 over 4 integral du. When I write that down, I always like to cancel off the 4x and the dx, because that's what shows up. What remains? U squared. What is the antiderivative of u squared? U to the third over 3, so I have u to the third over 12 plus c, or otherwise natural log of x cubed over 12 plus c. So I actually was wrong when we talked about this being set up as a 1 over u problem or a e to the u problem. It wasn't either, was it? It was just a substitution that involved the natural log of x. Yep, the substitution itself just worked out quite nicely, okay? We got 4 more problems. You have time to work. We good? Okay. Look at the next problem. And the next problem that you have looks like a challenging problem. This is the easiest problem on the homework and that you'll see on the test. And here's why. All we have to do is, normally people want to create this as a 1 over u type problem because they see something in the denominator. We're just going to divide. We're going to divide each term by x. 3x squared over x is 3x. 4x divided by x is 4. And then we have minus 2 over x dx. So I've told you before that if you have just one term in the denominator, it's often to your advantage to divide it and rewrite it. And we've set that up in multiple times throughout the calculus course. Now I just have to find the antiderivative of this. What's the antiderivative of 3x? 3x squared over 2 plus 4x. And the antiderivative of 1 over x is natural log, so the antiderivative of 2 over x is just 2 natural log of the absolute value of x plus a constant. Not too bad. So it did involve a natural log in the end, but you can see how we made that a pretty simple process by just dividing. And the same will come true for this next one as well. It does work out if you chose u to be x minus 1 on the bottom, but I'm going to make this easier by simply just dividing. I don't know why, but sometimes this becomes painful for people. We're just going to rewrite it by division. This is a strategy that I often use. I'm going to take x minus 1 and divide it into x plus 1. I'm just rewriting the problem. Okay? Remember doing polynomial division back in the day?
Yeah.
What do you multiply x by to get x? 1. So 1 goes there. We multiply it back through. 1 times x is x, and 1 times negative 1 is negative 1. I subtract these values. X minus x is 0. 1 minus negative 1 is positive 2. So that means I come up with the integral of 1 plus 2 over x minus 1. So I've rewritten it. All I did is just divided it to come up with the new expression. We did this last year in pre-calc on 2 different occasions. You did it back in Algebra 2. And now we just take the antiderivative. What is the antiderivative of 1? X. And the antiderivative of 2 over x minus 1. Okay, so you're right, Luke. I would like to show people why that is real quick. When you set this up, I'm going to show you a nice shortcut. A lot of times people say, well, u is equal to x minus 1. So du is simply just equal to dx, is it not? Anytime du is equal to dx, you could just take the antiderivative of that. So just like the antiderivative of 1 over x is natural log of x, the antiderivative of 1 over x minus 1 is just the natural log of x minus 1. The difference is you just attach the 2 out front. So anytime du is equal to dx, as it is in this situation, yep, you can just go ahead and not use substitution at all. So all of a sudden that becomes a little bit easier of a problem. Okay. Yeah. See why I have x minus 1 out here? And then x plus 1 goes here because you're dividing that into that. So you say, what do you multiply x by to get x? Multiply by 1. The 1 goes over the constant. Multiply it back through and you get x minus 1. Now we subtract. X minus x is 0. 1 minus negative 1 is positive 2. So 2 is my remainder. X minus 1 is my divisor. Yeah. Yep. Suppose you had x plus 3 goes into 9x. What 9x plus 8. So you would multiply by 9, and then you get 9x plus 27. Subtract and go from there. Yep. Better? Okay.
9 plus, sorry, 9 minus 21 over x plus 3.
I think we got 19 out of that. 19 over x plus 3, yeah. Better? Okay, last 2 examples. Talk to your peer. Decide what u is in this problem. What is u? Is it sine or is it 3 plus cosine? Talk to your friends. What do you think? Go. What do you think it is?
I think it's cosine.
Really? Why?
Oh no, it's not.
Shh. Eyes up here. Suppose, no, don't write that down. It's wrong. So suppose you choose u to be sine of x. Notice that that du, you never come up with the 3, do you? That's a problem. So we're going to abandon that option. We're going to say that u is equal to 3 plus cosine. And if you take the derivative, what's the derivative of 3 plus cosine? Yeah, du is equal to negative sine of x dx. So we're going to move the negative on over. Negative du is equal to sine of x dx. And I have a sine of x dx, so my substitution is negative integral du. What goes away is sine of x and dx. I'm left with 1 over u. Now it's easy form. The antiderivative of 1 over u is? Good. And for good measure, one more. What do you think? What is u here? Good. Square root of x minus 2. What is the derivative of the square root of x? 1 over 2 roots of x dx. As you notice, I don't have a 1 over 2 roots of x. I have a 4 roots of x in the denominator. Times it not by 2, but by 1/2. 1/2 du is 1 over 4 roots of x dx. My substitution is complete. I have 1/2 integral du. If this problem looks familiar, you had basically the same problem a couple tests ago, multiple times. So we have practiced this. I get to get rid of that. What remains? E to the u. And so you get 1/2 e to the u, which is the root of x minus 2, and plus a constant. There are 3 parts to your next test. The first part to your next test is these antiderivatives. After we do antiderivatives, we will also be doing slope fields, which is new, but it is easy. Easy. Trust me. People never get those wrong on the test. And then the last piece will be what we call separable equations. That's a little bit more challenging, but this test really could go well. So make sure you know this stuff well. Struggling to find my answer keys. And let's just put it like this. All the answer keys that I've had before that have been online, my websites have, my old websites, they've all kind of expired. They've expired because Google has updated their sites. So I need to do some work. It's going to take me some time. Unfortunately, right now I'm really short on time. So I'll do my best to get some answer keys ready to go. But why don't you just start by working on your homework assignment? We'll be good to go. I'm going to do my best to find them. I'm going to start working right now as soon as I possibly can.